8.4 goes over graphing functions in the form of a times x minus h to the second power plus k. The first thing that we're going to look at within this section is identifying even and odd functions. So the way that you do this is you're going to plug in positive 2 and you're going to plug in negative 2 for x in the same function. If you get your answer for plugging in the positive 2 and it's equal to what you get for your answer when you plug in the negative 2, you have an even function. If you plug in the 2 and you plug in the negative 2 and your answers are opposites, then it's an odd function. If you plug in the 2 and you plug in the negative 2 and they're neither the same nor they're opposites, they're totally different numbers, then it's neither. If we look at example 1, it tells us to determine whether each function is even, odd, or neither. So again, we're going to plug in 2, we're going to plug in negative 2, see what our answers are, and then compare them. When we compare them, that will give us whether or not they're even, odd, or neither. For example A, we have f of x is equal to 2x. So if we do f of positive 2, that's going to be 2 times 2, which is 4. So f of 2 is 4. If we do f of negative 2, we have 2 times negative 2, which is negative 4. Now you see that you're comparing the 4 and the negative 4 here. They are opposites. So we have an odd function. For example B, we have g of x is equal to x squared minus 2. So we're going to plug in the positive 2 first. We have g of 2 is equal to 2 squared minus 2. The 2 squared is 4. And 4 minus 2 gives us 2. So g of positive 2 is positive 2. We're going to do the same thing, but now with negative 2. So g of negative 2 is going to be negative 2 squared minus 2. The negative 2 squared is 4. And 4 minus 2 gives us positive 2. Now if you compare the 2 with the 2, they're the same. So this is an even function. For example C, we're given h of x is equal to 2x squared plus x minus 2. So we're going to do f of 2 first. It's going to give us 2 times 2 squared plus 2 minus 2. The 2 squared is 4. 4 times 2 is 8. Plus 2 minus 2. That 2 and that negative 2 are opposites, so they cancel out. So your f of 2 is just 8. If we then plug in negative 2, that's going to give us 2 times negative 2 squared plus negative 2 minus 2. The negative 2 squared is 4. 4 times 2 is 8. Minus 2 is going to give us an f of negative 2 is equal to 4. You see that this 8 and this 4 have no correlation with one another. So because there is no correlation between the 8 and the 4, they're two totally different numbers, this function is neither even nor odd. For example, D, we have f of x is equal to 5x. So plugging in the 2, it's going to be f of 2 is equal to 5 times 2, which is 10. Then we plug in the negative 2. It gives us 5 times negative 2, which is negative 10. These are opposites of one another. So we have an odd function. For example, E, we are given g of x is equal to 2 to the power of x. So if we do g of 2, we're going to have 2 to the second power, which is 4. And then if we do g of negative 2, we're going to have 2 to the negative second power. Remember, when we have a negative power, we take the reciprocal of the term it's attached to. So that's going to be g of negative 2 is equal to 1 over 2 squared. So that's 1 over 4. Now 4 and negative 4, when you compare them, they are not the same number, nor are they opposites. So even though they include the same number, they are neither for these functions. So neither even nor odd. Oops. For example f, we're given h of x is equal to 2x squared plus 3. So if we do h of 2 first, we're going to have 2 times 2 squared plus 3. The 2 squared is 4, times 2 is 8, plus 3 gives us h of 2 is equal to 11. For h of negative 2, we're going to have 2 times negative 2 squared plus 3. So this gives us the negative 2 squared is 4, times 2 is 8, plus 3. So h of negative 2 is 11. These two are the same numbers. So when you compare them and you see that they are the same, they give us an even function. The next part of your lesson, we are going to be looking at transformations within these functions. So it's going to prompt you to graph these. However, I'm not going to require you to graph them. What I want you to do is to state the transformation. So with these, the ones that we're going to be looking at right now, we're going to be given functions in the form of f of x, g of x, h of x, any of that is equal to a times x minus h squared. Your a, the term that's in front, directly in front of the parentheses, represents a vertical stretch or a vertical compression. If the number is between 0 and 1, it's a vertical compression. If it's greater than 1, it's a vertical stretch. Inside your parentheses, anything that happens inside your parentheses with any of these functions, you want to think opposite. So I understand that within this function, you have x minus h. You would think minus h, you're going to be going down or to the left or something to represent a negative. However, you have to think opposite. So that h that's inside the parentheses with the x, it represents a horizontal shift. So it's either going left or right. If it's minus h, you want to think opposite. The opposite of negative is positive. On a number line, the positive numbers are on the right, so it would be going to the right. If it was x plus h, that h would then be opposite of the positive, which would be negative. The numbers on the number line that are negative are to the left of 0, so that would be going to the left that many units. So our whole idea with these is to state the transformations. What type of vertical stretch or compression do we have, and by what factor? And then are we going left units or right units? If we look at example 2a, yes, it tells us to graph the function. However, I do not want you to graph it. I just want you to state the transformations. It gives us g of x is equal to 1/2 times x minus 4 squared. This 1/2 that you see here, it's a number between 0 and 1. So that gives us a vertical compression by a factor of 1/2. So we write vertical compression by a factor of 1/2. Next, you have that minus 4 inside the parentheses. That minus that's in front of the 4, take the opposite of it. It would be a positive 4. If you're on a number line, the numbers that are positive are to the right of 0, so you're moving right 4 units. So with these vertical stretches and these vertical compressions, it's literally widening going up or widening as going down in shrinkage. So literally, yes, it makes your line or your parabola wider or thinner. However, you got to look at this vertically. So if it's vertically stretching, it's like you're taking the top and the bottom, so wherever the vertex is and wherever your arrows are, and you're stretching it up. If it's vertically compressing, you're taking where that vertex is and where those arrows are, and you're compressing it, so you're shrinking it pretty much, so it's going to widen. But again, you want to look at that or think of it vertically, not horizontally. Okay? And then again, opposite inside parentheses, whatever the sign is in front of that H value, that whole number, take the opposite of, and it tells you right or left. For example, B, we are given g of x is equal to 2 times x plus 5 squared. With this one, we have that 2 that's in front of the parentheses. The 2 is a number greater than 1, so it gives us a vertical stretch by a factor of 2. Next, you have that plus 5. The 5 has a positive in front of it, so think opposite. Opposite of positive 5 is negative 5, so we're going to the left 5 units. For example, C, we're given h of x is equal to negative, or the opposite, of x minus 2 squared. Now, with these negatives, it's not included with the vertical stretch or the vertical compression. This negative is something different that I haven't gone over yet. It represents a reflection. So I don't know if you've realized this, but with what we've gone over so far, anything that's happening on the outside of parentheses is happening vertically, so up and down. Anything that happens on the inside of the parentheses is happening horizontally, so side to side. If you have a negative in front of the parentheses, it is a reflection, and it's a reflection going up and down, so it would cross over the axis. If you moved up and down, that would be the x-axis. So this negative that's in front represents a reflection across the x-axis. If the negative is in front of the so-called coefficient or the number that you're multiplying to the parentheses, it's a reflection across the x-axis. You will also have reflections across your y-axis if you have a negative coefficient of x inside the parentheses. So if that negative was inside the parentheses in front of the x, it would be a reflection across your y-axis. From here, we do have that minus 2 inside the parentheses, so think opposite. It would be plus 2. That means we would go to the right 2 units. All right, so for our next part, we're looking at not only your vertical stretch and compression, but also your right and left transformation, and now your up and down transformation. So your terms that are on the outside of your parentheses are happening vertically, up and down. They are what you see. So if your k value, your number that's on the outside of the parentheses after the parentheses, if it's a plus k, you're going up that many units. If it's a minus k, you're going down that many units. Okay, so a couple things to remember here. Negative in front of the parentheses, in front of that a, you have a reflection across the x-axis. The a, if it's a number between 0 and 1, it's a vertical compression by that factor. If it's a number greater than 1, you have a vertical stretch. On the inside of your parentheses, if you have a minus h, you're going to the right that many units. If it's plus h, you're going to the left that many units. And lastly, on the outside of the parentheses, if you have plus a number, so plus k, you're going up that many units. If you have a minus number or a minus k, you're going down that many units. If we look at example 3a, we are given g of x is equal to negative 2 times x plus 2 squared plus 3. So we're going to go part by part with this. First thing that we see is this negative in front of the 2. We said that the negative in front of the parentheses, in front of the number being multiplied by it, is a reflection across your x-axis. So that negative represents a reflection across the x-axis. From here, the next number that we see is that 2. That 2 is a number that is greater than 1, so that means we have a vertical stretch by a factor of 2. Next, on the inside of the parentheses, we have that plus 2. Think opposite. Since it's inside the parentheses, that would give you a negative 2. Negatives are to the left on the number line, so that means that we're going to the left 2 units. Lastly, we have that plus 3. That's our k value. It is positive, so it is what we see. We're going up 3 units. For example B, we're given g of x is equal to 3 times x minus 1 squared plus 6. So for this one, we're going to start with the 3. The 3 on the outside in front of the parentheses means that we have a vertical stretch because it's greater than 1 by a factor of 3. Next, on the inside of the parentheses, we have that minus 1. Think opposite of negative 1, that's positive 1, so we're going to the right 1 unit. And lastly, we have that plus 6. It is what you see since it's on the outside of the parentheses, so we're going up 6 units. And lastly, for example C, we have h of x is equal to 1/2 times x plus 4 squared minus 2. We're going to start with this 1/2. That 1/2 is a number between 0 and 1, and it's on the it's in front of the parentheses. So that means that we have a vertical compression by a factor of 1/2. Next, on the inside of your parentheses, you have that plus 4. Inside parentheses, think opposite. So it's going to be negative 4. So we're going to the left 4 units. And lastly, we have that minus 2 outside the parentheses after the parentheses. So we're going down 2 units.